Okay. I think I need about another negative 15 or so. I don't know for sure. Negative 27? Okay. Then we'll make it negative 30, just to make it a nice round number. You don't have to. I just like nice round numbers there. Okay. Yeah, one more change is going to help. We'll make this a negative 5. Okay. So what did we find out? We said that the critical numbers are x equals 4, x equals 1. Does it look like possibly that could happen? X equals 1, x equals, now here, 1, 2, 3, 4. Now again, it's a critical number, but is it an extrema? And it doesn't look like it because it does not change direction. Okay, so we've got that. Now, the next thing is to determine the second derivative of x. And the second derivative of f of x, rather, second derivative is the derivative of the first derivative. And so we're going to have to go back up. Now, which of the first derivatives do you want to take? Do you want to take this sum that you got, or do you want to take the product? Would you like to distribute it through, as someone mentioned before? You decide what you want to do. I'm going to use, let's see, what did I use in my work? I used the product approach to it. Hope you're not watching me. I hope you're doing your own. Again, I hope you're not watching me. I hope you're doing your own. And I hope we agree. You must have this line of derivatives that you intend to take. Show me your work all the way through. Once we get this done, we want to determine critical numbers of the first derivative, which means setting the second derivative equal to 0. What I'm doing now is going back to my graph. I've got some critical numbers. I'm going to put some points there. Just see what happens here. And so I'm just going to go back and make sure that I've got the critical numbers where I say they should be. From the graph, I can see a lot, right? From the graph, it's kind of obvious what I'm looking for, maybe. Maybe. What are we looking for in the problem? Discuss the concavity. Okay. Now, we've got something significant happening here. Take a look at your critical numbers, especially this one. X equals 4 is a critical number. And let's be more specific, it's a critical number of the function. In other words, it was a 0 of our first derivative. It also happens to be a critical number of the first derivative. Now, I'm going to show you one more thing before we finish this up. The last thing we're going to do is we're going to determine the second derivative at the critical numbers of the function. In other words, at the zeros, let's put it that way, the zeros of the first derivative. So we've got critical numbers of the function. Those critical numbers of the function were x equals 1 and x equals 4. These are the critical numbers of the function. Way up here. I'll highlight this one too. If I take those critical numbers and I put them into the second derivative, we already know that at 4, the second derivative is 0. We just found that, didn't we? It's one of the zeros of it. What happens, though, when I put 1 into the second derivative? let's see, if I put 1 into the second derivative, I have 12 times 1 minus 4 times 1 minus 2. Do I need the exact value, or what am I going for? Positive or negative? That's all I need to know from this. Why is that important? If the second derivative is positive, what do you know happens at that critical number? If it's positive, the curve is concave up, which means then that at that critical number you have a minimum. If at that critical number the second derivative is positive, let's say if it's negative, it's concave down, you have a maximum. If it's positive, you have concave up, you have a minimum. Okay, so it's important only to know what the sign is. This is kind of like your sine curve in a way. So let's see, you've got 12 times negative 3 times negative 1. Second derivative at 1, is it positive or negative? It's positive. Therefore, f of x at x equaling 1 is, or has, let's say, a minimum. We can also say because it is concave up. Okay, we can go back to our curve. Is it concave up? Okay, yes it is. Now, at 2, well, let's see. At 2 and 4, those are the critical numbers of the critical numbers of the first derivative. So what is happening at 2? It's not a 0 of the first derivative. It's not a 0 of the first derivative. That's good for us because if it happens to be a 0 of the second derivative, this is a on the function. This is where the function does what? Changes concavity, making this a inflection point. Okay, if it's not a 0 of the first derivative, but it is a 0 of the second derivative, we can conclude, definitely conclude, that it is where it changes concavity. Now, look at the graph. Would you say that's where it changes concavity? To the left of that, is it concave up? If I have the shade on here, from here to here, would you say it's concave down? Okay, and we have an extrema down here. So what is it about 4? 4 shows up in both of those. Is it also an inflection point? Yes. It's also on this side is concave down and that side is concave up, but it's not. It does not signify an extrema, and that's what we would try to say up here on the first derivative, that it's an extrema. It's not an extrema. Not an extrema because the second derivative at 4 is also 0. It's a 0 of both of those, so we have to be careful about those. If they show up in both of those, take a real good look at them. They may or may not be extrema. They may or may not be inflection points. Is it an inflection point? Yes, it is also an inflection point. So it says discuss the concavity. I kind of ran out of space on my mine right here. So our conclusion is, I'll just put it right here. Conclusion is f of x is concave up where? Give me an interval.